what does polarity have to do with ideal gases? Let's use two gases as our example, O2 and ammonia. If I draw the Lewis structure for O2, I get a linear symmetrical molecule. So that tells me this is, if I draw the electron density, it's distributed pretty evenly. Whereas for ammonia, if I draw the Lewis structure, there's a lone pair on top, so it's going to be a bent molecule. And when it's bent, it's polar. Why is it polar? Because the electron, this isn't symmetrical, so the electron density is going toward the nitrogen. So the nitrogens are partially negative and the hydrogens are partially positive. There's a partial charge. Okay? So ammonia is polar and oxygen is non-polar. So that's step one, identifying whether it's polar or non-polar. What does polarity have to do with gas behavior? So if I have, which I do in nature, right? Ammonia molecules don't exist by themselves. There's a bunch of ammonia molecules around. So they are all behaving the same. They're all going to have this partial positive on the hydrogens and partially negative charge on the nitrogen. What happens when I have different charges, opposite charges, close to each other? What's going to happen here? What do you think? Right? There's going to be this attractive force pulling them close together, right? This intermolecular force, the IMF, the attractive force here. Okay? But for oxygen, right, I'll also have oxygen molecules around. There's no positive or negative side to the molecule, so they're not going to attract each other the same way that ammonia molecules will. Ideal gases, the assumptions state that they do not have strong attractive forces. Okay, so look at the assumptions and you'll find that this is true. They don't have strong attractive forces. So if that's true for ideal gases, what type of gas, polar or nonpolar, would most likely behave ideally? Nonpolar gases will behave ideally because they do not have strong attractive forces. Whereas polar gases will behave like real gases. So they do not follow the assumptions, okay? Because they're polar, they have attractive forces. And because they have attractive forces, they're going to get near each other. They're not going to bounce off each other and have more collisions, okay, which affect ideal gas behavior. So they will not behave ideally because of that attractive force.